Good day, everybody. Thank you so much for tuning in to Bright Future YouTube channel. My name is Quadria Shaumba Shavanzela Shankangatela Regini. Nimjoamba Mina Chavinchumunti Chavala Maika. So today we're going to be doing chapter 1 of geography, which is climate and weather. Remember, I posted a video of some of how to answer certain questions. They'll be asking you some of the terminologies that you need to look out for when you are answering geography questions, more especially paper 1. So now today we're going to be doing climate and weather, which is of course paper 1. This chapter covers secondary, which is regional is usually provincial, and tertiary, which is local, circulations or weather pattern. This knowledge will enable you to answer weather patterns and microclimates of cities and valleys in the exam. So in this diagram, I'm not sure as to why they did not label it, but this diagram shows you the core unit, which is climate and weather. It gets to be divided into secondary circulation, which is regional, and tertiary circulation, which is local. Under secondary circulation, we have SA climate, synoptic weather, global air circulation, cyclones. And under tertiary circulation, we have local climate. And then under SA climate, we have ocean and ocean currents. We have plateau. We have subtropical high pressure belt. So these are what we're going to cover on our chapters. And then we have under cyclones, we have mid-latitude cyclones, tropical cyclones, characteristics of cyclones. And then on local climate, we have anabatic and katabatic winds, aspect and climate, city climate. So as you can see, they're written 1.2, 1.21, 1.11. So that's the unit we're going to cover. So first of all, we're going to go for synoptic weather 1.1, which falls under secondary circulation. From there, we're going to 1.1.2, which is global air circulation baseline, just like that. 1.1.3, that's if we have it. On this one we don't, so we're going to go for 1.2, which is the cyclones, and then go to 1.21, 1.22, 1.23, just like that. From there we're going to SA climate, and then we're going to cover 1.31, 1.32, 1.33. So yeah, just like that up until we're done with our chapter. So let's move on. So we got key concepts for this unit. If you know and understand the definition in this chapter, you will be able to answer most of the questions in the climate and weather, which is climatology, which is called climatology section of the final exam. Use your mobile notes to learn these concepts well. See the page for instruction on how to make them. Adding pictures to your mobile notes will help you remember the concepts. So let's go for the definition first. So these are some of the definitions that we're gonna have to understand when we are dealing with this chapter, where we under unit of climatology. The first one is anabatic winds. These are warm winds that blows up the valley slopes during the day. So you need to know what anabatic winds are. Sometimes you'll be asked to define these concepts. Anticyclone, which is high pressure, forms as a result of sinking air. Air movement is anti-clockwise, divergent outwards, subsiding, sinking in the southern hemisphere. South Atlantic high, South Indian high, and Kalahari high. So those are the 3 kinds of high pressures that we have. So you need to know what an anticyclone is, so you'll be able to identify it in a diagram. Aspects: the direction in which a slope faces. So you'll be told in a question or a paragraph or a sentence that you're given that you have aspects. When you have that, just know that you have the direction in which a slope faces. It's called an aspect. The berg winds. These are hot, dry winds that blows from the interior of South Africa to the coastal areas. So it blows from inside the interior of South Africa to the outside. Those are berg winds. And then you have climate change. When they ask you to define climate change, this is the definition: long-term changes to the global climate. Underline long-term changes. So that's what actually shows you that this is a climate change. It happens during a very long time. It's a change in a long term, resulting in unusual and extreme stronger weather conditions. So it could be too much sun, too much rain. It's just too much of the weather. So that is climate change. Cyclone, it's a low pressure. Remember, we had high pressure, which is anticyclone. Now we have cyclone, which is of a low pressure. So each and every time when they say in a statement that you have a cyclone, just know it's a low pressure air. And then if you have high pressure air, it's anticyclone. So they just say, when they give you a question, they just say anticyclone. They won't tell you it's high pressure. So you have to know that it's high pressure. So a cyclone forms as a result of rising air. Air movement is clockwise, convergence inwards, rising which is convection in the southern hemisphere. Coastal low, tropical cyclone, mid-latitude cyclone. So those are the types of cyclones that we have. So as you can see, anticyclone is the opposite of cyclone: high pressure, low pressure. So you need to draw, I would suggest that you draw a table and then you draw the differences of anticyclone and cyclone, so you'll be able to understand properly, so that you don't forget in your exam. And then we have heat island. Higher pressures in urban areas than the surrounding area. There are many causes of heat island, including pollution. Invasion layer, the zone where sinking cold air meets with the rising warm air. That's an invasion layer. A layer of the atmosphere in which temperature increases with height. You have to know the definition. They'll ask you what's an invasion layer in a one-term word, or maybe they'll ask you to match it up with its definition. Intertropical convergence zone, an area along the equator where the tropical easter lies from both hemisphere meets. So this is the hemisphere, the northern and the southern hemisphere meeting. Where they meet is called the intertropical convergence zone. Katabatic winds, these are cold winds that blow down a valley slope at night. Remember, anabatic winds, they blow during the day. Polar easter lines, winds that blow from the pole towards subpolar low pressure belts, 90 degrees to 60 degrees. Temperature inversion, this is the temperature increasing with height. The thermal belt, the zone of warmer temperature above the valley flow. Tropical easter lines or trade winds, winds that blow from the subtropical high pressure belts towards the equatorial low pressure belt. Western lies, winds that blows from the subtropical high pressure belt to the polar low pressure belts. We will get to understand more of these when we're dealing with when we're analyzing a picture. Now let's start with our introduction. So our focus will be on the southern climates, mid-latitude cyclones, tropical cyclones, subtropical anticyclones, and local climate, valley and city climate. That's the local climate. But first we need to understand synoptic weather charts, which are maps and satellite images, before we move on. So synoptic weather maps are often tested in an exam, so you need to know how to analyze the synoptic weather. So let's go for synoptic weather interpretation. To better understand weather patterns and weather phenomena, you need to be able to interpret the synoptic weather map. A synoptic weather map is defined, here's the definition. It shows weather conditions and phenomena: temperature, precipitation, wind speed and direction, atmospheric pressure and cloud coverage over a wide area at a given time, based on worldwide observation recorded at the same time from weather station, airplanes, weather balloons and satellites. On a synoptic weather map, there are lines called the isobars. This line joins points of equal pressures all along one isobar. The pressure is the same. The pressure is measured in hectopascals. The isobars form patterns, shapes formed by many isobars. So as you can see, this is an example of an isobar. All these lines. So if you see an isobar or a line, just know that throughout that line the temperature is the same and it is measured in hectopascals. Here is a note. Please note that the pressure reading decreases towards the center of a low and increases towards the center of a high. Here's an example. So as you can see, this is a low pressure cell as seen on a synoptic weather chart, and then this one is a high pressure cell as seen on the synoptic weather chart. So on the chart you'll be able to identify these two. So we were told that as in a high pressure cell, as you move outwards, the pressure decreases. As you move inside towards the center, the pressure increases. For a low pressure cell, from the center towards the outside increases, but from the outside towards the center it increases. You need to be able to identify these in a synoptic map. So it looks like we're given an example. Figure 111C on page 4 shows a simple weather station. It describes the weather of a particular place that is found on a synoptic map. In the exam, you may be asked to describe the weather of a particular place on a synoptic weather map. By referring to the weather station, you will need to comment on the following weather elements. So these are very important. You should be able to know, if you're given a synoptic map, what you actually need to look for when they say analyze that synoptic map of a certain or a particular area. So you need to know the cloud coverage, the wind direction, the wind speed, air temperature, dew point temperature, precipitation, any form of water falling from the sky. Any form of water falling from the sky is called the precipitation. So now these are the elements that you actually need to describe when they say analyze the weather station of a particular place using the synoptic weather map. So they say in here, remember your compass points to the direction of the to determine the wind direction. So if it's pointing this way, which is on my right, it means it's going to the east. If it's going that way, it's the west on your left, and then going up it's your north, and going down it's your south. Note the following weather conditions for this weather station. This is what they were telling us. The wind speed is 15 knots. So it was calculated. So 1 bar is 10, and then when it's half, it's 5. You can assume any value that you want. You can say 14, 13, but 1 bar is 10. Wind direction, it's northwest. Air temperature is 27 degrees. Rain precipitation, sorry, it's rain. And then dew point temperature is 24. Cloud coverage is overcast. So definitely you'll need to know this is 1 bar. This is what we're analyzing. So the temperature on the top always is the air temperature. The temperature at the bottom, it's the dew temperature, and how much of the dot is filled in here will tell you the cloud coverage. And then these bars will tell you the speed, and then where this is facing will tell you which direction is actually facing, which is the northward at this point. So I would suggest that each and every time you find a drawing like this, you just say, put your paper straight up, and then you draw a line, a compass line like this. Then you'll know that on the second quadrant you have west, and then the first quadrant you have, sorry, you draw the Cartesian plane. On the top part is north, the south path is south, the right path is east, and the left path is west. So it falls on the second quadrant, so it definitely has to be northwest. So you definitely need to do that. I would suggest you guys do that. Now let's analyze these symbols. You need to know the symbols, but you're definitely given, you just need to know, you just need to be able to analyze them. Now here is what I was talking about, the cloud coverage. So when it's just around without being colored, the cloud is clear. When it's covered 3/4, it's cloudy. When it's covered fully, it's overcast. And then when it comes to speed, when this knot is quarter, it's 5. When it's full, it's 10. Again, like I said, when it's this, it's 10 and 15. When it's 2 of this, it's 20, because it's 2 10s. Precipitation, when you have a dot, it's rain. When you have this of like a semicolon corner, it's drizzle. And here's showers, snow, hail, fog, mist, thunderstorm, and thunderstorm with hail. But you're going to be given those symbols on your synoptic weather. So I think, because I don't want to make this video long, let's continue with this. Let's continue with this on our next session. Thank you so much for tuning into this video. I really appreciate it. I hope you enjoyed your first lesson for geography. If you have any questions, put them on the comment section below. I'll definitely make sure to answer. If you need a private tutoring, just let me know on my WhatsApp number. It's on our first and the last part of the video. Thank you so much.